Welcome back, everyone. In this lesson, we're going to go ahead and take a look at collections in Python. Collections are also called sequences, and they're a data structure that allow you to store multiple pieces of data. If you worked with arrays before, that's basically a collection. In this lesson, we're going to go ahead and take a look at lists, tuples, and sets in Python. Let's go ahead and take a look at each one. I'm going to create a brand new Python 3 notebook. I'm going to call it 005 collections. And I'm going to make a comment here first. Whoops. Collections. And get the spelling right. Are also called sequences. We will look at lists, tuples, and sets. Let's start by looking at lists. These are created using the square bracket operation. So I can create a courses list by simply doing this, and this is an empty list. You can take a look at what's in it by simply doing that, and you see it returns an empty list. If I wanted to, I could type in courses is equal to, and let's put in some stuff here, history, math, physics, and let's say coding. Now you're not restricted to just putting in strings in this case. I could put in a number. Just because it's called courses, it doesn't mean that you can't do that. If you look at this now, you can see it dumps everything out for you. Excuse me. Now there are a bunch of functions available for you, so I can say what is the length of courses. Using the length function, it tells you it's 5. Remember that in Python, the indexing starts at 0, so history is in position 0, math is in position 1, etc. If I wanted to, I can do slicing, as we saw before. I can say I want to look at 1:3. And notice it returned math and physics, this being 0, 1, 2, 3, and you may recall that the first index is included, but the last index is not included. As I mentioned before, a good way to remember this is to do the difference between the two. So 3 minus 1 is 2, so you expect to get 2 results back. Lists are considered mutable objects. That is, they can be modified. I can type in courses.remove that number 3, for instance, and then take a look at courses. You notice that 3 was dropped, which is wonderful. If you know exactly what you want to drop, you just type it in and it will drop it for you. You can also append by using the append method. I can say append, for instance, art, and take a look at courses. And you notice that it appended it to the very end. Let's continue on. I can create another list called more courses, and this is equal to, let's say, English and drafting. Let's take a look at more courses. English and drafting. I can take my existing courses and call the extend method. And before I go any further, when you put the dot, you can press the tab key here, and it actually gives you the methods that are available. In this case, I want to say extend. Okay, so I can do that too. It's kind of handy to be able to do that. And I'm going to put in more courses in there. So I'm extending my courses list with another list. And this is going to come in quite handy for us later. Let's take a look at courses. You can see that English and drafting was added. What if I want to insert something in a particular position? For instance, I can take courses, and instead of saying append, I can say insert. In position 2, I want to put in chemistry. And let's take a look at courses. And we can see that this is position 0, 1, 2, so it put it right here and pushed physics to the side. So this 0, 1, 2, so chemistry is in fact in position 2. Very handy. We also have the option of popping a value, which returns a value. So I can call the pop method. It returns a value. Let's actually do phy is equal to courses dot pop position 3, which is physics. Let's actually take a look at physics. And you can see physics was returned. Now take a look at courses. And notice that physics was actually removed when you said when we actually did pop over here. And that's a very important distinction. When you pop, it actually pops it out and it's removed from the original list in this case. We haven't really discussed for loops yet, but I am going to throw it in here because the for loop in Python is so powerful. It can actually loop over a collection without you having to have an index to keep track of it. So we'll have a whole lesson on for loop, but here's a little intro. I can say for item, an item is just a placeholder in courses, colon, and notice the indentations. The first time we've actually seen this, that you may recall I told you that in a previous lesson that Python cares about indentation is actually how it keeps track of blocks of code. And Jupyter Notebook actually does the indentation for us automatically when we put a colon here. So I'm going to type in print item. And you can see that it went through and it actually did this for loop for us, which is wonderful. In Python, you may recall I told you that a string is really a list of characters or a collection of characters. So if I type in a message and type in it's coffee time, this is more or less treated like a list. I can say for m in message, print m. And it actually treats every character as an entry, which is really handy. Let's take a look at using the in operator. Does something exist in the list? I can say print math in courses. And it says it's true. Yes, math is in fact in courses. We can take a look at courses and math is in there. Let's take a look at programming. And I'm not going to even say print in it. I don't have to. Programming in courses. And you can see that it says it is false. I thought I turned off all these notifications, but apparently I haven't. In any case, let's go ahead and take a look at something else. Let's take a look at indexes in this case. I'm going to type in to get the index. So this is index 0, 1, 2, 3, 4, 5, 6. We can use the enumerate function. Okay, this returns the index and the value, which is really handy. So I'm going to do a for loop for I, comma, C. As you can see with a for loop, you can actually have two things. So we're saying we want to get the index and the course. That's what INC are short for, in, and we'll call the enumerate function. So enumerate courses. Print the index because it returns that. Also print this little funny thing and the course. And take a look, it actually brought the index and the values back for us. That's a wonderful feature of enumerate that returns both the index and the value from a collection. Doesn't have to be a list, but right now we're dealing with a list. Okay. We can choose the index ourselves if we want to. We can choose the index ourselves. This is kind of handy, so if you don't like the zero-based stuff, you can actually say for I, comma, C in enumerate courses. And what I can say is I can say start the indexing as 1, for instance, and then print I, comma, little arrow, comma, C. And notice this time we're basically doing it this way. I'm not a huge fan of doing that. We will have I think a problem that I will make this change because it makes sense, but it's generally it's best to just leave it alone. We can also use the join method because if you think of a string as basically a collection of characters, the join method can come in really handy. Using the join method with strings. Let's see what this does. So I can say courses under string is equal to semicolon dot join courses. So we are taking the list, which is the list of our courses, and we're joining everything using semicolon. Let's actually go ahead and print courses string. And notice it actually returned this wonderful string, which is semicolon separated. You can think of it as creating sort of a CSV, a comma separated value, except we're using semicolons. If I put commas in here, of course, it would put commas for us. Notice that Python is clever enough and it doesn't add a semicolon to the very last one. It stops for the very last one. All right, let's take a look at courses again. Great. We can also use the split method, and this is a wonderful method. It's very useful. This one creates a list from a string. So this is the reverse, if you will, of join. Let's take a look at courses string, which is that. And then I'm going to basically create a new list. And I'm going to say, you know what, take courses string, call the split method on the semicolon. Okay. And let's say I want to take a look at this new list. And notice it recreated our list for us, which is fantastic. I want to point out that if you don't put anything in here, if you don't put a semicolon or a comma or anything in here, the split method will assume that the split is over a space. So keep that in mind. I'll make a note of it actually right here. No param means split over space. Okay, so that's basically what I wanted to cover for lists. Let's take a look at tuples. So tuples are another collection. Tuples are immutable. That means they're unchangeable. Very importantly, use the comma to create them. Most people think that it's the parentheses. It's not. Let me go ahead and create schools is equal to GMU, and let's say GWU. And I'm going to print type school. Okay, schools, sorry about that. So notice it says that it is of type tuple. Now I want to point out that the parentheses are not necessary. Let's take a look at this one. Schools is equal to, let's say, Stanford, MIT, and GWU. And then print type schools. You can see it's still a tuple. So the parentheses is to make it look a little more professional, but it's not necessary. To be sure, if I say t is equal to 9 in parentheses, and then type in print the type of t, notice it says it's an integer. However, take a look at this one. M is equal to 9, comma, and then print the type of M. And notice it's a tuple. Because I added that last comma, it became a tuple. How do you create an empty tuple? Which is quite useless. To create an empty tuple, you do it by saying E, for instance, equal to the tuple method, and then print the type of E. Why is it fairly useless? Well, because tuples are immutable. So as before, you can actually go through the elements of tuples. I can say schools, for instance, here, but I can also say schools, 1:2, and you notice it return MIT with that extra comma in there. But if I wanted to do something such as append, if I say schools dot, and you can press the tab key, the only things you have is count and index. Let's say I pretend that I can append something. I'm going to try to append, for instance, GWU. It's already there, GMU, let's say. And you notice you get, it has no attribute append. So tuples are immutable. Remember that. All right, let's take a look at sets. Just a few notes here. Values are unordered because they are based on sets in mathematics, and no duplicates are kept. Again, just like sets in math. If you remember your math when you work with sets. Duplicates are removed. Use curly braces to create. Let's actually take a look at an example right here. So I'm going to create set courses is equal to curly braces. Let's say coding, math, physics, and coding again. And take a look at set courses. Notice that the extra coding was dropped. It just kept coding, math, and physics. We have still the options of checking for things. I can say print is math in set courses. And the answer is true. Let's take a look at art courses, another set that we're going to create. I'm going to have this be art, drafting, and coding. Let's take a look at art courses. Shows all of them. I can do a set courses and call the intersection method with art courses. And notice that they intersect on coding. I can do set courses and do the difference with art courses. So basically it takes a look at the set courses, which is coding, math, and physics. What's the difference between that? Well, the difference is that we have math and physics here, so we take out the difference, which is coding, so it returns basically what's left, math and physics. As you might expect, we do have union. So set courses dot union with art courses. Again, because the coding is duplicated, it's thrown out. So we just get art added and drafting added to it that were not in the previous ones. Okay. Let's take a look at creating empty versions of all of these. There are two ways of doing that for both of them. So creating empty list, tuple, and set. And we saw it for tuple, but I think it's important for you to see it because you might be surprised. Let's take a look at empty list. You can create it using that, or empty list can be created using the list method or the list constructor. Okay, so that works. Empty tuple. Empty tuple, as you recall, you create, if you just say open close parentheses right here and empty tuple can also be done by calling the tuple constructor like that. Now remember, if you just put something in the middle of this, it doesn't work. You also have to put the comma in there. Now, interestingly enough, for an empty set, if you do just this, it doesn't work. You would have to create an empty set by calling the set constructor, like that. Let's actually check that out. I'm going to come here and put in my set is equal to this, and then print type of my set. You notice that it will say it's actually a dictionary, and we'll have another lesson on what dictionaries are. But to be sure, I wanted you to see that by using just the curly braces by themselves, it doesn't create a set, it creates a dictionary. So to create an empty set, you need to call the set constructor with the parentheses. All right, that's it for our first introduction to collections. We'll be using these all the time. Thank you for being a wonderful audience. If you're enjoying these, please share with loved ones and friends.